There it is. Jack usually mows his lawn in 5 hours. Marilyn can mow the same yard in 6. How much time would it take them to mow the lawn together? So let me write the key facts. Jack needs 5 hours. Marilyn takes 6 hours to mow the lawn. How long together? Do you like word problems? Are there your favorites in your list of favorites? Do you think I like word problems? Do you think I always liked word problems? Yeah, so I just want to help you to know you can go from having troubles and word problems to being able to do word problems. I am living proof. I hated them. I don't know if you think I'm a math teacher. I just popped out of the womb loving math and loving word problems. I hated them. I remember when I was in high school, first encountering word problems. When I was taking Algebra 1 and Algebra 2 high school, I had Mr. Allison. He was tough. He was not just a PE coach filling in for the math class. He was serious about math. He had his math degrees. Had been in the Navy. He still had his buzz cut. He was like 50 years old, and he still had his buzz cut. And he was just, you didn't mess around with Mr. Allison. He taught calculus at that school. He was the tough guy, and he just, I don't know if you think I'm serious about math. He acted like math is life. He's so serious about it. He was a good teacher. He was probably part of why I'm an algebra teacher today. Anyway. One time he messed up on a word problem. Log going down the river. I don't remember the details. He messed up, had a little trouble on the board, fixed it the next day. But he had trouble that one day. And I remember talking to my little friend on the phone. I had a little friend, Jeff Broberg, I still remember. He looked just like the kid on A Christmas Story. Remember with the glasses? That's what he looked like back then. Anyway, and I'm talking to him and saying, see, these word problems are too hard. Nobody can do these things. Mr. Allison messed up, right? These are crazy. And anyway, but eventually I learned to do word problems by just a couple hours of work. No, I spent hours and hours and hours and hours and hours and hours, but eventually they make sense. So these kind in particular were interesting to me. I mean, I hated them all, but they intrigued me because when I would read a problem like this, I go, hey, Jack can do the lawn in 5 hours, Marilyn can do it in 6. How long if they work together? Jack in 5, Marilyn in 6, put them together, 11 hours. No, that can't be right. Can't take longer. But it felt right. I don't know if you feel that way. I would read it, and my gut would tell me, you got to add something. They're working together. They're combining their efforts. You got to add something. When people work together, when things are combined, you got to add something. I go, I know you got to add something, but if you add 5 and 6, that's 11. It can't be 11. This is weird. I remember being intrigued by these. So, what do you guys think? Before I give you, step 1, step 2, step 3, that gets a little boring for me. I don't think it's a little boring for you. Let's just think about it. Let's just think reasonably about it. Any thoughts? And it doesn't have to be a perfect thought. Just we'll hem and haw around and fix it eventually. But any first thoughts? Like, how might you do this problem?
Would you add and divide by 2?
Yeah, that's not a bad idea. Right? Just add them and divide by 2. What's that called when you add 2 things and divide them by 2? That's averaging. Exactly. That's how you average 2 things, right? And you do that, you get 11 over 2, which is 5.5, which is the average. It's the middle of 5 and 6, isn't it? That makes sense. It's the average. It's the middle of 5 and 6. Add them and divide by 2. What do you think about that as the final answer? Let's just, maybe, 5.5 hours, right? Could that be the final answer? What do you think? What does your gut tell you? Too long?
Yeah.
Why too long?
I don't know, because it just doesn't seem right to me, the numbers.
Yeah.
Yeah.
What particular numbers?
How Marilyn can mow the lawn in 6 hours.
Right.
And then how he does it in 5 hours. Why is it taking longer?
What's longer than what?
Mowing the lawn. Why is it 5.5 hours if they work together? Because Marilyn's doing it in 6 hours and Jack does it in 5 hours. So why does he need Marilyn? He can do it by himself.
Well said. Exactly, right? I mean, if Jack can do it in 5 hours alone, and then Marilyn comes to help and it takes 5.5 hours, Marilyn's not very much help, right? So something's wrong there, right? That can't be the answer. The answer cannot be higher than 5, can it? Or Marilyn's no help at all. the real answer has to be lower than 5, doesn't it? You with me? Hey, here's what I mean. Let's have some. These are good. Let's have another logical thought. What if Jack took 6? What if they both took 6 hours? Just to make it simpler for a minute. What if I said, hey, each of them can do it in 6 hours alone? Just to make it simpler, you know. What if they combine their efforts? It'd be 3 hours, right? We all agree it'd be half the time. If they were nice, even, same numbers, then together would be half that 3 hours. We agree? That seems reasonable. That's true, isn't it? Right? If both of them took 6 hours alone, then together it'd be half the time. They're both mowing at the same time, half the time. Be 3 hours. It'd be 3 hours together if they were both 6. That's true. It'd be 3 hours. The answer would be 3, so the answer is not 5.5. But it would be 3 hours if they were both 6. But they're not both 6. Jack's even better than that. He's even a little faster than that. He can get done in 5. So therefore, the real together answer has got to come out even a little better, lower than 3. Doesn't it? It's got to be 2 point something, doesn't it? You with me logically? See how we logically concluded that has to be the case? Because if it was 6 and 6, together they'd have that 3 hours. And they're a little better than 6 and 6. Jack's a little quicker. He can get done 5. So it's got to be something lower than 3 hours together. It's got to be 2 point something, doesn't it? The real answer. Well, that's good reasoning. That's all true. So we're expecting a real answer that's 2 point something. If it takes Jack 5 hours to mow the lawn, if I say, hey, Jack, I want you to go mow the lawn, he starts mowing the lawn, and after 1 hour I go, stop! How much of the lawn did Jack get mowed? In 1 hour. In 1 hour. If Jack can do the whole lawn in 5, what portion of the lawn does he get done in 1 hour? Right, 1/5, right? 20% is correct. 1/5. Does that make sense? Right? If it's 5 hours for Jack to do the entire lawn, then he gets 1/5, 1/5, 1/5 done every hour, right? Every hour he gets 1/5 of it done. You with me on that? Now, how about Marilyn? If it takes her 6 hours to do the entire lawn, if I stop her after 1 hour, what portion of the lawn does she have done? 1/6, huh? So this is Jack in 1 hour. This is Marilyn in 1 hour. You with me? So Jack in 1 hour can get a 5th. So if I just start both of them, I just go, Jack, get your lawnmower. Marilyn, get your lawnmower ready. Mow. And they start mowing, and I stop them. After 1 hour, Jack would have 1/5 of the lawn done. Marilyn would have 1/6 of it done. And I could add them up to get how much they get done together in 1 hour. Right? Whatever that would add up to be. You with me? Now, on the other side, the together, what if somebody just whispered the answer in my ear? The answer's 2, let's say, I'm guessing, 2 hours together. It's not the real answer, but let's just pretend. In fact, let's just pretend it's 2. So if it does, well, let's pretend it's 3. I don't want to confuse you with the 2. Let's pretend it's 3. What if somebody just whispered the answer in my ear? It'll take them 3 hours together. Let's just suppose. If it does take them 3 hours, if they're both mowing, both of them, Jack and Marilyn, both mowing, done in 3 hours, right? Got a big old lawn, right? And Jack's mowing, and Marilyn's mowing, done in 3 hours. Maybe, I'm just making up a number. 3 hours. What portion of the lawn would they get mowed working together in 1 hour? If I said, Jack, Marilyn, ready, mow, and then stop after 1 hour, what portion of the entire lawn would be mowed? If they can do the whole thing in 3 hours. I know they can't, that's not real, but I want to get the logic. If it takes them 3 hours to do the whole job working together, after 1 hour, what portion would they have done? Well, 1/3. It's just like the 1/5 and the 1/6 thing. Now, I know that's not true. That's not the real answer. But you're good with me logically, right? However, so you notice you can turn times into portions by flipping them, can't you? You ever stopped and thought about that late at night? Thought, if how long it takes to do something It takes me 10 hours to write that English paper. That means, flip it, I get 1/10 of the paper done every hour. Right? Maybe you have. Maybe you're not that strange to think about those kind of things late at night. All right. Anyway, you get the idea, right? So if it takes them 3 hours to get the whole lawn done together, it doesn't. That's not the answer. But then 1/3 is done every hour, right? So whatever portion Jack gets done every hour, plus whatever portion Marilyn gets done every hour, is the portion they get done together every hour. Now, it's not 1/3 because it doesn't take them 3 hours together. How long does it take them to get the lawn done together? Well, I don't know. In fact, that's the question. So let's call it X, because I don't know how many hours it takes them to mow the lawn together. That's what I'm trying to figure out. It's X hours together, right? Together. So what should I do with that X? 1/X, right? There's our equation. Does that make sense? The portion Jack gets done is 1/5 every hour. The portion Marilyn gets done every hour is 1/6. If it takes them X hours to do the whole thing, then the portion they get done every hour together is 1/X. Does that make sense? Remember when we thought it was a 3? If it takes them 3 hours together, then they get 1/3 of it done every hour together. So if it takes them X hours together, since I don't know what that is, then they get 1/X of it done every hour together, don't they? Does that make sense? There's our equation. It's portions. So you should add. What you should add is portions of the lawn. Jack gets 1/5 of it done every hour. Marilyn gets 1/6 of it done every hour. If it's X hours together, then they get 1/X of it done together every hour. So the portion they do alone adds up to be the portion they do together every hour. There's our equation. So I won't go through that whole spiel, ever again. Just once and for all. So from now on, all you have to do to solve these problems is to put 1/1 of the times plus 1 over the other time, 1/X, and then solve that equation. Let me go to a fresh screen and we'll solve that equation. So 1/5 plus 1/X is plus 1/6 is 1/X. Solve that equation. All right, so how do we solve that equation? LCD, equal sign, left, right, LCD, top, top, top. The whole LCD, right? Not just the missing part. Whole LCD, top, top, top. What's the whole LCD there? 30x. Everybody good? Because just multiply them all together. 5 times 6 times x, right? 5 times 6 is 30 times x is 30x. So 30x, 30x, and 30x. Good? So far, so good? 5 goes into 30. 6, and remember you cross cancel. Multiply what's left over. So we get 6x. 6 goes into 30 5 times. 5x. X cancels x. 30. Good? 6x plus 5x is 11x. Equals 30. How do we solve for x? Divide by that 11. Yeah. You guys have a calculator? What's 30 divided by 11? 2.7? Look at that. Just like we thought. It's just under 3, huh? The real answer. So there it is. There's how you do that. Now, I think Math Excel wants the fraction. I think they want the 30 over 11. Questions on that one? So let's do a couple of these. We got 15 minutes till our break. These are the same every time. You'll whip through these. It's just always 1 over a plus 1 over b is 1 over x every time. Can I flash off that? Y'all got that down? Because you're adding up portions of the job. All right. You don't even need to read the words. Lisa can shovel, blah, 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 blah. 40 minutes, somebody else, 55. And then they say, how long working together? So when you see one of those working, you just go 1 over a plus 1 over b is 1 over x. That's the formula we're always going to use. That's a b there for the working together. So it's going to be 1 over 40 plus 1 over 55 is 1 over x. Does that make sense? You just grab the 2 times and put them underneath the 1 because that gives parts. And then we have to solve that for x. How do we solve that for x? we multiply through by the LCD. And you know what, guys? Rather than, you could put the 40 and the 55 in a box and find the LCD, but you know what? It's easier just to use everything. Let's just do that. Use the whole LCD. So I'm going to go 40 times 55 times x. 40 times 55 times x. 40 times 55 times x. That makes sense? I just do the whole LCD, top, top, top. 40 times 55 times x. And then cross cancel and multiply whatever's left over. Right, so the 40 cancels 40, and I get 55x plus 55 cancels 55, 40x, and x cancels x, 40 times 55. Bless you. And that's what, 95x equals, somebody have that over there? Like 2020 or something? 2200? 20,200? Oh, thanks. Like that, thank you. Good to there, so 95x is 2200 divided by 95. And that's just it. I don't think that reduced. Oh, 5. You can divide by 5, huh? Whoops, my mistake. Divide by 5, top and bottom, of course, ending with a 0, huh? Divide by 5. Divide by 5. Somebody got that? What is that? What is it? Thank you. 440 over 19. There we go. Is that good on that one? Does it make sense how to do these working together? It's just 1 over the first time plus 1 over the second is 1 over x. And then to solve, you just multiply through by the whole LCD. Everything. And then cancel what you can, multiply the leftovers. No questions? I flash out that. We'll try another one. They're the same every time. Okay, so we got 50 minutes, 65 minutes. How long together? So you know what to do, right? Same equation. 50 and 65 are your two numbers. Is that good? 1 over 50 plus 1 over 65 is 1 over x. And then just multiply through by the LCD, which is all three. $50, 65, and x. like that, and then cancel whatever you can. We good to there? Last step. Y'all getting these okay? Divide by 115. So that fraction's reducible, huh? Over 23? Thank you. There we go. Is that good? These okay? These working together ones is pretty easy, right? Not too bad. Okay. So that's number 4. Okay. Speed of a passenger train is 8 miles an hour faster than the speed of a freight train. So we're changing gears. We'll do one of these and then we'll take our break. We're changing gears here to a new kind of word problem. These are travel. So we did the working together, now we're going to do the travel. These are the hard ones. And then afterwards we'll do the easier ones again, which are ratio. So speed of a passenger train is 8 miles an hour faster than the speed of a freight train. Passenger train travels 300 miles in the same time it takes the freight train to travel 260. Find the speed of each train. So what equation do you use for travel? Anybody know? What's the equation from physics for traveling?
It's like D equals RT.
Yep, D equals RT. Distance equals rate times time. Distance equals rate times time. What we're going to do is make 6 boxes, 2 underneath each letter. Like that. The top row is for the passenger train. And the bottom one is for the freight. So we have a passenger train and a freight train. And they're traveling. All right, and let me write out for you the game plan. Here's the plan for the boxes. Here's the dirt. There's I had a student years ago that called that the dirt equation. So that works. That helps. So it's like the word dirt. The equals is like the I. Here's the plan. Step 1. Get the left 4 boxes from the words. Step 2. Get the last 2 boxes from distance over rate equals time. Like that. Okay. And so how do we do this? What are we talking about? So first off, let me make sure that the boxes are making some sense to you. Like, what if I put a 10 in that box? What would that mean real life? It's not right. We're not going to put a 10 there, but what would that mean real life if a 10 was there? That would mean the D for the passenger, right? That would mean the passenger train goes a distance of 10 miles, right? D stands for distance. Now, what if I put a 10 down here? What would that mean? Distance for the freight train, right? That would mean the freight train went 10 miles, right? That's what that would mean. It's not what they're saying. But what if I put a 10 here? What would that mean?
Faster there goes 10 miles an hour.
Yeah, the rate, the speed, rate means speed, right? Miles per hour. Yeah, for the passenger train, it was a slow train, 10 miles an hour. And if I put a 10 down here, that means the freight train went at 10 miles an hour. Those are how fast the freight trains are always going when I'm stopped at the signal light waiting for them. They seem like they're going 10 miles an hour. All right, so now, what if a 10's right there? What does that mean?
The time, I guess, for the passenger
Time.
to
Like 10 hours. So that means the passenger train takes 10 hours to make its trip. And if the 10's down here, freight train takes 10 hours to make its trip. We good with the meanings for the boxes? Okay, now let's try to do the step one. Get the 4 boxes from the words. Okay, here we go. Let's take the words. Can you all see the words okay? 8. The passenger train is 8 miles per hour faster than the freight. So the passenger train is 8 miles an hour faster than the freight train. What do we do? 8 miles an hour faster. That's like saying 8 more, isn't it? His speed is 8 more, 8 faster, 8 more. What do we do in a word problem whenever they say something's 8 more?
8 plus
X plus 8, 8 plus X, either way, the order doesn't matter on the adding. Yeah, that right, that always means X plus 8, and then also somewhere else there's a plain X. You with me? Isn't that what it always means on a word problem? When they go blah, 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 8 more, something's 8 more, we go, oh, it's X plus 8. And also there's a regular X somewhere. Okay, well, what's it saying? Passenger is 8 faster. So the passenger, is that the, which box are we talking about there?
the rate.
Rate, speed, miles per hour, speed. So right here, X plus 8. Does that make sense? And the other one is X. Because the passenger train is 8 added to whatever the freight train speed is. The freight train's X, this is that at 8. Right? Good so far? Now, it says, what else does it say? So there's that fact. The passenger train travels 300 miles. 300 miles. Is that distance, rate, or time? That's the distance for the passenger train. Distance for the passenger train. In the same time that it takes the freight train to travel 260 miles. That's the distance for the freight train. We good to there? So far, so good? Now, I got 4 boxes. That's step 1. Step 1. Get the left 4 boxes from the words. Got them. Step 2. Get the last 2 boxes from, now what is this and where did this come from? What it is I just took the equation, D equals R times T, the dirt equation, and I said, look, I need to know T. I need to get the last 2 boxes. I need to find out what T is. So I took this little equation and said, hey, here's the equal sign. Can I solve for T? Can I get T alone so that I know what the T boxes should equal? How do you solve for T here? Divide by the R. And that's how I got that little formula. The T is D over R, right? So therefore, this T box is the D box over the R box. And the bottom T box is the bottom D over the bottom R. Is that making sense? In other words, get this out of the way here. So I say this is 300 over X plus 8. It's D over R. And this is 260 over X. It's the D over the R. Is that good? The T box is D over R. The T box is D over R. So I've got the T boxes. They're D over R. Okay, great. That's step 2. That's how you get those last 2 boxes. You get the first 4 boxes from the words. The last 2 you get from the dividing. Now, step 3, remove the last two boxes and write an equation. Right, so grab those last two, this one and this one. So 300 over x plus 8 equals 260 over x. Does that make sense that I set them equal? Remember, they're underneath the letter T, aren't they? They're under the letter T, which means they're time quantities. What in the words, what words up there tell us that I can set these two boxes equal to each other, these two time amounts? How do I know these two time amounts, the time for the passenger train and the time for the freight train, are going to be equal? How do I know the two times are going to be equal?
Same time.
There it is. See it right here? Same time. The freight train, the passenger train, they do their thing in the same time, which means equal time, doesn't it? That's how I can set these two time boxes equal. Okay, so now you just need to solve that equation. We got our equation. These are hard, aren't they? These are complex. So how do we solve that equation? What are we going to do? Two equal fractions? Cross multiply, right? Diagonal, diagonal. I'm going to come up here and keep working. So what do we got? 300x equals 260 x plus 8, diagonal, diagonal. So 300x is distribute. 268 plus, what's 8 times 260? 2080? Thank you. And then you got to get x alone, so subtract 260x from both sides. What's that? 40x is 2080. Divide by 40. X equals something, I don't know. 52? Thank you. X was 52. Is that okay? So we solved that equation? Just cross multiplied and then got x alone. Because we're almost done. There's just one more small step and we're done. Are we ready to move to the very last step? That x is not quite the final answer, but it is the key that'll unlock the door to the final answer. So everybody hear me on that? Because x is not, you got to go back to the question. Yeah. So what are they saying? The speed of the passenger train, speed of the freight. They want to know the speed. They could ask you for any of these 6 boxes, and you could get it now because you now have the key. You could plug 52 in anywhere you want and find out any of those things, right? Now that you have the key, all those doors can open. It's just a matter of which door or doors do they want opened. Well, they want the speed of the passenger train and the speed of the freight train. Where's speed? Which boxes are speed? Yeah, they want this one and this one. That's the speed of the passenger and the speed of the freight. The rate is the speed. Take that x, 52, put it in right there, put it in right here, because x is now 52. The mystery's over. We now know what x is. 52 plus 8? 60. And this one's just 52. So the speed of the passenger train is 60. The speed of the freight train is 52. And we're done. That's the hardest kind of word problem we'll do. This type, the travel ones, are the hardest we'll do all semester. Does that make sense? Questions I can answer on that one? So the dirt equation, 6 boxes. You get the first 4 boxes from the words. The last 2 boxes come by dividing. Left over middle, left over middle. Then you grab out those last 2 boxes, set them equal. Cross multiply, cross multiply, solve. That's the key. Unlock the doors they want. All right, well, we need a break, and we'll do one of those after break. So 10-minute break, huh? You want to try one of those dirt problems, distance, rate, time ones? There's one, should be very, very similar to the train one we just did. So try to, same kind of thing. do the D equals R times T. And we're talking train A and train B instead of like freight train, passenger train. We're talking train A, train B. All right, so remember you get the left 4 boxes from the words. Can you read all those words? I can write some of them up here bigger. It says A is 18 miles an hour slower than B. And it says A 220 miles, B 210 miles. There we go. So you can do that. So get the left 4 boxes from the words and the right 2 from dividing. So A is 18 slower than B. What do we do with 18 slower? Yeah, that's in the rate box, huh? X minus 18 and the other one's X. Everybody getting that okay? That makes sense. 18 slower, X minus 18, and that's for A. That's A's rate. Then the A is 220 for the distance, and the B is 310. Okay, so we've got 4 boxes from the words. That's what we always do. We always get those left 4 boxes from the words. Now get the right 2 boxes by dividing. So divide those 2 on the right. So 220 over X minus 18, 310 over X. We good there? You always take left over middle, left over middle. And then we grab these 2. 220 over X minus 18. And 310 over X, and you set them equal, right? You always grab out those last 2 boxes and set them equal because it says same time, right here, same time. So those 2 time quantities are same, are equal. So now we cross multiply, huh? Diagonal, diagonal. Cross multiply and solve for X. See if you can finish it from there. So 220x is 310 times x minus 18, good. And then distribute. So 310x was, what's 18 times 310? Somebody got that?
5580.
5580? 5580. Thank you. Here's the wall. We good to there so far? Is that making sense? How we doing? Am I racing ahead too quick? Is this okay? And then we got to get x alone, so subtract 310x from both sides. Gonzo. So then we get, I don't know what, 8 minus 90? Minus 90x equals minus 5580. Oh, kind of running out of room down there. Come up here. Minus 90x is minus 5580. Last step to get x alone. Divide by minus 90. I don't know.
62.
What is it?
62.
62? Thank you. 6 is, and it's positive because 2 negatives make positive. 62. Now that's the key. Careful. That's not the answer. That's the key that will get us the answers, right? They want to know the speed of the trains, don't they? They want the speed of A and speed of B. So that's here and here. So plug in the 62. 62 minus 18. What was that? 44? 44. So that's the speed of train A, 44. And this one is just straight 62 for B. Does that make sense? So remember, when you get your answer for X, you take that and you unlock the door. You plug in 62 for X, plug in 62 for X because X is 62. So you plug 62 in both X slots, subtract 44 and 62. Those are your speeds. And we got it. There it is. Questions on that one? We all good? All right, because they're going to get trickier than that. You good with the basic kind? Now, this one says same time. The next one is not going to say that. In fact, it's going to say one of them is too shorter, one of them is too longer. What that means is instead of setting the two time boxes equal, we're going to have to subtract them to equal the difference. Does that make sense? If you ever thought about it before, if somebody says, if I say, hey, I'm 3 years older than my brother, I'm the older brother, I'm 3 years older. That's not any different than if I say my brother is 3 years younger. That's the same thing being said two ways. I'm 3 years older, he's 3 years younger. Same fact. Either way, my age, subtract his age, equals 3. The difference is 3, isn't it? Do you hear me? Does that make sense? Logically, if somebody tells you that one thing is more than another or one thing is less than the other, either way, no big deal. In both cases, they're telling you how different they are. And that means their difference, their subtraction equals 3, or whatever the difference is. Does that make sense? So if on this problem they said, hey, train A is 3 more, speed. Speed is 3 miles an hour more. No, not speed, we're talking time, huh? Time. 3 hours. It takes train A 3 hours longer to make his trip. Instead of they do the trip in the same time, if it said A is 3 hours more, then I would have taken the A formula minus the B formula, this minus this, to equal 3. Does that make sense? Because they would have been telling me A is 3 more, so that's a difference of 3, right? What if they'd said B is less by 3? Same thing. Still means the difference, the subtraction, equals 3. That make sense on that? That's what they're going to change up now. So save that for the end. Save the time stuff. Because they might put that sentence right in the beginning. Hey, train A takes 3 hours longer than B. Don't stick it in the table. You remember how you get these guys in the table? By dividing, right? Remember, you get the left 4 boxes from the words and the right 2 boxes by dividing. Then pay attention to whatever they're saying afterwards about time being more or less or whatever for your equation. All right, let's see it. So number 8. So the trip was during a snowstorm 80 miles. Made a trip 80 miles, and then the first trip was 80 miles, and then the return came back. The return trip at double speed took 2 hours less time. Save that fact for the end. 2 hours less time. Save that fact for the end. See what you can do. Is that making sense? So distance is rate times time. Like that. Hey, there's not 2 trains here. Train A, train B, freight train, passenger train. What are the 2 things? First and second trip, or first and return, yeah. First and return. First trip and then return trip. Well, yeah, good. So see if you can get the left 4 boxes from the words and then the right 2 by dividing, huh? And save that 2 hours less time. That's going to be the difference is 2, isn't it? That's going to be subtract the 2 times, it equals 2. Right? If one's more, one's less, whatever, they're different by 2. Right? See what you can do there. How we doing? Okay, the first trip takes 80 miles. That's distance, right? 80 miles. If the trip takes 80 miles, how much does the return trip take? Same, huh? It's the return trip. It's same distance. Even if they did it faster or whatever, it's the same distance. And then the rates, what does it say? Double speed. Double speed. So the return trip is double speed. So 2x for the return, x for the regular. Does that make sense on that double speed, 2x? We good with those? So we got the 4 boxes. Got the left 4 boxes, I mean. So how do we get the, so keep going from there. You know how to get the right 2. You divide, huh? You always get the right 2 by dividing, and then pull out those 2 and subtract them to equal 2. Does that make sense? Because somebody's 2 hours less. That means they're different by 2. Right? If my brother's age was 2 less, that means our difference is 2. Right? Our subtraction is 2. Everybody seeing that? Because I think students get thrown off. They think they need to do something like for less, they got to subtract, and more, they got to add or whatever. No, not in this case, because we're making a comparison. Right? Like I said, if I told you I'm 3 years older than my brother, or I said, hey, my brother's 3 years younger than me, my age is 3 more, my brother's age is 3 less, whatever, the difference is 3. Those are all meaning the same thing in the end, aren't they? The difference is 3. The subtraction is 3. 80 over x, 80 over 2x. Over x, 80 over 2x. And then the difference. Over x minus 80 over 2x is 2. Does that make sense? The difference, the subtraction, equals 2. That's what this is saying. Can you solve it from there? So now we have three parts to it. So we have to do common denominator, right? What's the common denominator here? Yeah, it's going to be 2x, isn't it? Everybody see that? It's going to be 2x. So we got to go 2x, 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 right? Because we don't just have 2 fractions, so we can't just cross multiply. We have 3 things, so we need to multiply by 2x, 2x, 2x. All 3 of them. All 3 of them. So cross cancel. Multiply the leftovers and solve. Cancel the x's. And so what do we have? 2 times 80, 160. Cancel the 2 x's. Just 80. 2 times 2x, 4x. Why don't I cancel them over here? That's not under a bar. They just multiply, huh? Everybody see that? Everybody good to there? So then that's 80 equals 4x. Last step, divided by 4. X is 20. But careful, that's the key. Go unlock the door. What do they want? You got to go back to the question. The speed going. The speed going there. Where's that? Which of the 6 boxes is the speed going? That one, huh? First trip rate. It is just X, so it turns out 20 is just the answer. We don't need to do anything with it this time. They could have asked me for the speed on the return trip, though, and I would have needed to double it. Or they could have said, how long did the first trip take? I could have plugged in 20 there. 80 over 20 would have been 4 hours, etc. They could ask all kinds of things. And I can answer them all. Once you have X, you have the key to unlock any door. Good on that? All right, time is a running. You okay if I move on from that? So much math today. Okay, Bob is just as fast as Enan. It's a funny name, Enan. Okay, Bob is 2 hours more than Enan to drive to town. Bob is 78 miles from town. Enan, 52 miles. There's the key facts written out for you. Okay. All right. Dirt equation, set up the 6 boxes. Remember, same thing. You got to get the left 4 boxes from the words and then the right 2 by dividing. Same setup. Get the left 4 boxes. What do you do with Bob is just as fast as Enan? Their rates are the same, so what do I put in their rate boxes? Yeah, they're both just normal X. That makes sense? Just as fast, equally fast. And one's not double the other. One's not 3 more or 2 less. They're just as fast. They're both X and X. Is that good? Okay. And then Bob is 78 miles. Enan is 52. Okay, I've got 4 boxes. How do I get the 2 on the right? By dividing, as you know. Right? 78 over X. 52 over X, the left over the middle. You good? Does that make sense so far? Okay, now what does it say? Great, now grab those 2 time boxes. Grab those 2 time boxes. This one and this one. 78 over X and 52 over X. What am I going to do? Am I going to set those equal? Does it say they are same time? If it said same time, then same would mean equal. But it doesn't say same time, does it? What does it say about time? I'll let you handle it. There's one other fact I haven't used, right?
2 hours more.
Yeah, 2 hours more. 2 hours more, so do what you need to do about that. So what do you do when it's 2 hours more? Remember, more or less means difference is 2. It means the difference is 2. Remember, it doesn't matter if they say more or less. Either way, you're declaring a difference. If I say, I'm 3 years more than my brother, or if I say my brother's age is 3 years less than mine, whatever. Either way, I'm saying the same thing. I'm declaring that we're different by 3. Right? You see that? You don't need to stress out about more or less for that. Either way, it means their difference is 3. You just got to make sure you have the bigger one first, and we do. Why? Bob. Bob is the more. Bob's fraction is front. The bigger one is first. It's good.
Or you can think of it as 78 over x, and you think that Bob is 78 over x, and you add 2 in the equation, and then 52 over x, and then you subtract 2. Subtract 2, would that be 1 or no?
Well, if I tell you one thing is bigger than another, and you want to make them equal, you can either subtract 2 from the big guy, or you can add 2 to the little guy. That would also work.
Okay.
Yeah. Or you can just say they're differences too. Yeah. All right, so there's the equation. Can you solve it? Go ahead and solve that equation for x. And then answer the question. We'll be done with these kind of word problems and move on to the easy kind. And then the last section, which really isn't hard either. We're right here. This is the last of the hard stuff. All right, so what's common denominator? X, yeah. Let's multiply x, x, x. Good? Cancels, cancels. What do you got? 78 minus 52 is 2x. What is that? 26 is 2x. Divided by 2. X is 13. We got it. 13's the answer. You can tell by that tone I'm being goofy. 13 is not the answer. Why not? Now, careful. We've got to make sure we answer the question. Wouldn't it be a bummer on the test on next Tuesday, the big high-stakes test, the hardest of our tests, the test that exalts some people and throws other people down, right? You don't want to be the down thrown. Anyway, to do all that good work, and then they do this too. Those publisher tests I use, they'll put the 13 right on there. They're just baiting the hook and throwing it in the waters of your test. And they're saying, bite, baby, bite. Bite on that 13. Just grab it. And you don't want to grab it because you're hooked if you grab it. 13 is not the answer. Wouldn't it be a bummer to do all that good work and it'd be like intercepting the football, running 99 yards, and right in the goal line you trip, right? You're just about to score. Don't trip now. What needs to be done here? What's the problem? Why are we not done? Because remember, X is not necessarily the answer on a word problem. You got to go back to the question. Don't forget that. How long does it take, Aaron? It's one of those boxes. This is the key, but that's not the door. It's the key. We got to unlock the right door. Which door? How long does it take, Enan, not Aaron, Enan. How long does it take, Enan? What's that? Which box do they want? Distance, rate, or time? How long? Time. Enan time. Right there. They want the Enan time box, don't they? They want me to stick the 13 in for X right there. They want 52 over 13, which is 4. That's the answer to our problem. So don't forget on word problems to actually go back and answer the question. They want how long for Enan? 4 hours is the answer. 13 is X. Plug it in for X right there in Enan's time box. 52 divided by 13 is 4. Good? We good with those? I really need to move on. No time. No, I'm kidding. Hopefully close to no time because we got to get another section done. All right. So they're saying there's some kind of animal that has 3 pounds of muscle for every 7 pounds of weight, body weight. And if you got a 154-pound animal has how much muscle? So you got this type of animal that's got 3 pounds of muscle for every 7 pounds of weight. That's It's a lot of muscle. It's half muscle. 154-pound animal has how much muscle? So these will be real nice and easy. These are just going to be like A over B equals C over D. It's just two equal fractions. They're called ratio. Word problems is our last type in this big word problem section. We've had working together, which is 1 over A plus 1 over B is 1 over X. We've had travel, the dirt kind. Now we're having ratio, two equal fractions. Okay, so you see what we're going to do here? I'm just going to go 3 over 7. 3 over 7 equals, and that's what? That's pounds over, well, that's muscle. They're both pounds, but that's muscle. Muscle over weight is, and where's the 154 go? Top or bottom? Bottom because it's weight. And up here is going to go muscle. We don't know that. That's X. Does that make sense there? 3/7 equals X over 154. Everybody see that? Then cross multiply and solve. 3 times 154 is 7 times X. What's that? 4, 15, 12, 4, 462. Thank you. Is 7X. Am I going too quick? Is everybody tracking with me on this? Just two equal fractions. And the only reason I write down the muscle weight is to help me make sure I don't get it upside down. You don't have to, but just be careful, right? You don't want to put the only thing you can mess up on is getting one of them upside down. Just be consistent. You can put weight on the top and muscle on the bottom, doesn't matter. Just be consistent with whatever you decide to do. Do the same thing left and right side, whatever. So I just did muscle over weight, so I did muscle over weight. The 154 had to go on the bottom. Cross multiply, so they're always going to give you, in all these problems, they're going to give you three numbers, and you find the fourth one's X. Cross multiply, solve for it. They're the same every time. So last step to divide, to solve is to divide here. Divide by 7. Both sides, boom. X equals, what's 462 over 7? 66. Thank you. There it is. We're done. Good? Questions on that? These will be your favorite kind of word problems. These are easy. Just A over B equals C over D. They'll give you three numbers. The fourth one's X. No questions? You good? All right.